go. We're doing the mean value theorem for integrals, 3.11 notes. Our goal is to apply definite integrals to problems involving the average value. That's the key term here. Okay, the average value. So let's start with example 1. Let's say we have a car that travels with the velocity given by the function v of t equals 4t minus t squared. And the graph is also shown below. And they're asking, what is the average velocity? Okay, so this is a v graph. The average velocity. And don't be confused by average acceleration. Okay, because this is a velocity versus time graph. So if they're basically asking for average velocity, what they're saying is, okay, at 0, my height is 0. At 1, my velocity is 3. At 2, my velocity is 4. And we got 3 again, and 0. Okay, now if those were our only data points, we can average them, right? Add up all the points divided by 5 points. But the problem is we have a point here, we have a height here, a velocity, 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 velocity. We have infinite amount of data points in this case. And so the question is, what is an average velocity? Okay, so if we put them all together, what do you think is kind of like the, I don't know, like maybe it's around here, maybe that would be the average height or the average velocity. Okay, so how I think about this problem when I think average velocity, you can use a cooking analogy. Okay, so from 0 to 4 is kind of like your boundaries. I kind of call that my box. So I'm going to do it in green. Here's t equals 0. So I'm creating a box here. And t equals 4. Those are my boundaries. And your x-axis, t-axis. Okay, so there's your box. Okay, now imagine that this red stuff is flour inside your box, like baking flour, right? Now, if that was a heap of flour and I want to find the average height of that flour, what would you do to figure that out? And it's pretty cool. What you would do is you would shake this flour up until all the flour levels out and turns into something like this. And then all the flour is now that, right? But what's the key idea? The key idea is that the area of the curve is equal to the area of the rectangle. Okay, and so let's kind of break this down. How do you find the area of the red curve? The area of the red curve, isn't it just the definite integral from 0 to 4 of 4t minus t squared? Right? That's the area under the curve. Equals, now the rectangle is just the length times the width, right? Or let's do this. If we have the height here, that is our average velocity. So I'll do v average. Okay, that height is your average velocity times, and what is our base? It's just 4. So how do we find the average velocity from our equation that we have? All we gotta do is divide both sides by 4, and there you have it. Your average velocity is going to equal 1/4 times the integral of 0 to 4t minus t squared dt. And why don't we finish up the problem? So this is going to equal 1/4 times the integral would be t squared minus 1/3 t cubed, going from 0 to 4. And so that equals 1/4. Plug 4 in, so I got 4 squared. Oh, I made a mistake. It's not t squared, it should be 2t squared. So 2 times 4 squared minus 1/3 times 4 squared minus if we plug 0 in, I know it's going to be 0 minus 0. Okay. When we plug all those things in, we get 1/4. 2 times 4 squared, 16 times 2 is 32, minus 4, oh, I made another mistake. It should be 4 cubed. 4 cubed is 64, so 64 over 3. Okay, and then we got that, and why don't we do some fraction stuff? So 1/4, 32, if I want to have a common denominator, multiply by 3, that'll be 96, the common denominator. So we got 1/4, 96 minus 64 is just 32 over 3, and 32 can divide by 4, which would give us 8, so the final answer is 8/3 is our average velocity. And they don't give us units, so there you have it, 8/3. And you can also check that by doing, if you go to your graphing calculator, I'm gonna turn this guy on, you go to math, and if you go to the ninth one, FNINT, and I can go from 0 to 4, and I know it's 1/4. What just happened? Okay, so math, FNINT, you can go to 0 to 4 of 4x minus x squared dx, and that gives us a value of 10.666, but remember we need to multiply by 1/4 or divide that by 4, and you get 2.67, which is the same thing as 8/3. And hey, we did our definite integral correctly. Okay, so that's how you would get the average value. So let's kind of recap for a general case, right? So we have the average value. To find that, what we did is we first compared the area of the curve, and we set it equal to the area of the rectangle. And for a general case, the area of a curve is just going to go from a to b of some function, and the area of a rectangle is going to be the average value. So why don't I call it the average of the function? Okay. So average is going to be f of avg. That's going to be the average value. That is the height multiplied by the base. Now for a general case, what would be the so let's say we have a function, and we have, oh, that's an ugly function. Let's do it differently. Let's say we have something like this. So here's A, here's B, So for my blue rectangle, that's my average. And my base is going to be b minus a right there. So for our final equation, an average value is going to equal 1 over b minus a times the integral of a to b. Okay. Now, how did I do that? I just simply divided both sides by b minus a. Okay. And there you go. This is the general average value equation. Let's practice. Let's find the average value of this function here. Okay, so now I don't really like memorizing formulas, so I just know the concept that the two areas of the curve and the area of the rectangle are always going to equal each other. The area of the curve is just the integral from -2 to 1 of my function x squared plus 1 dx. And the area of the rectangle is going to be the average value, which is the height multiplied by the base, which is 1 minus -2. And so my average value is going to equal 1 over, what's 1 minus -2? Is that 3? Distance of 3, yeah, 3 of -2, 1 x squared plus 1 dx. Okay, now I can take the definite integral and all that good stuff, but I'm going to do some calculators because I don't want to do that right now. So once again, I go to math, I go to number 8, which is, 9, the integral, and we're going from -2 to 1. Our function is x squared plus 1 dx. We get an integral of 6, but we need to multiply that by 1/3, which gives us 2. Hey, the average value is 2. Okay. All right, so let's do practice number 2. If a particle's velocity is v of t equals 1 over t, find the a, average velocity, and b, average acceleration. Okay, so this can get a bit confusing, but the average velocity, because we're given the velocity function v, so the average velocity is the average value. So v average is going to equal 1 over b minus a. I happen to memorize the formula because I remember the concept so much. And you go from the a to b of v of t dt, which is equal to 1 over 4 minus 1 integral from 1 to 4 of 1 over t dt. Okay, for this one we can just evaluate the antiderivative, not so hard. So it's 1/3, and the integral of 1 over t is the natural log going from 1 to 4, and so we get 1/3 natural log of 4 minus 1/3 natural log of 1. And we know that the natural log of 1 is just 0, so the answer is 1/3 natural log of 4. So how do we do the average acceleration then? It's just the slope, right? So it's the final acceleration minus the initial acceleration over the difference. So a of 4, oh, I am so sorry, not a of 4, but the velocity of 4, okay? So we end up getting 1 over 4. If I plug in because I remember v of t is equal to 1 over t. So when you plug in 4, you get 1/4, and when you plug in 1, you get 1 over 1, all over 3, and that could be your answer. But if you're not satisfied, here we go. We got 1/4 minus 4 over 4, which is over 3, and so we get negative 3/4 over 3, which is just negative 1/4. Sweet.